Welcome to our channel. Today we're diving into the fascinating world of EDM, Electrical Discharge Machining. If you're curious about how this advanced manufacturing process works and its different types, you're in the right place. Now, you might be thinking, EDM? Sounds like something out of a sci-fi movie. And you wouldn't be entirely wrong. EDM is like something out of a science fiction film, but instead of zapping aliens, it's used to create incredibly precise parts for everything from airplanes to medical devices. We're talking about tolerances so tight they make a human hair look like a telephone pole. And the coolest part, it uses controlled sparks to erode metal. Yeah, you heard that right, sparks. It's like a tiny lightning storm happening inside the machine, and the results are mind-blowingly accurate. First up, we've got Wire EDM, which stands for Wire Electrical Discharge Machining. Imagine this. You have a block of metal and you need to cut a super intricate shape out of it, like maybe a gear with tiny teeth or a complex logo. Now, you could try to machine that with traditional tools, but good luck getting those tight corners and smooth finishes. That's where Wire EDM swoops in to save the day. Picture this. A thin wire, thinner than a human hair, is threaded through the metal workpiece. This isn't just any wire though. This wire is charged with electricity, and it's submerged in a special fluid called dielectric fluid. This fluid acts as an insulator and a coolant, preventing the wire from just melting into a puddle of molten metal. Now, as the wire gets close to the workpiece, a spark jumps the gap. This spark, my friends, is where the magic happens. Each spark is a miniature explosion, vaporizing a tiny bit of metal and eroding the workpiece with incredible precision. The wire moves along a programmed path guided by a computer, and slowly but surely it cuts through the metal like a hot knife through butter. The beauty of Wire EDM is that it can create incredibly intricate shapes that would be impossible to achieve with traditional machining methods. We're talking about internal corners sharper than a lawyer's mind and surface finishes smoother than a baby's bottom. But wait, there's more. Wire EDM isn't just about cutting out fancy shapes. It can also be used to create slots, tapers, and even threads. And because the wire is so thin, it can create incredibly delicate parts with minimal material waste. So what kind of materials can Wire EDM handle? Well, pretty much any conductive material is fair game. We're talking about steel, aluminum, titanium, even exotic alloys that would make a metallurgist drool. This makes Wire EDM a go-to process for industries like aerospace, medical, and tooling, where precision and material properties are critical. Think about it. The next time you're on a plane, marveling at the engineering prowess that keeps you soaring through the air, remember that Wire EDM probably played a role in creating some of those critical components. From turbine blades to fuel injectors, Wire EDM is helping to push the boundaries of what's possible in aerospace manufacturing. And speaking of pushing boundaries, let's talk about medical devices. Wire EDM is used to create everything from surgical instruments to implants, all with the same mind-blowing precision and accuracy. These are parts that literally go inside the human body, so you better believe they need to be perfect. But it's not just about high-tech industries. Wire EDM is also used in more everyday applications, like creating molds for plastic injection molding. These molds need to be incredibly precise to produce consistent, high-quality parts, and Wire EDM delivers in spades. Alright, let's move on to the second type of EDM, which is die sinker EDM. Now this one's a bit different from Wire EDM. Instead of using a thin wire, die sinker EDM uses a shaped electrode to erode the workpiece. Think of it like a cookie cutter, but instead of dough, we're using sparks to shape metal. Here's how it works. First, an electrode is created in the negative shape of the desired cavity or feature. This electrode can be made from a variety of materials, like copper, graphite, or even tungsten, depending on the application. Once the electrode is ready, it's mounted to the EDM machine, and the workpiece is submerged in, you guessed it, dielectric fluid. Now, as the electrode is lowered towards the workpiece, a voltage is applied, and those magical sparks start flying again. But here's the cool part. Because the electrode is shaped like the desired cavity, the sparks erode the workpiece in the exact same shape. It's like a mirror image being created, but with electrical discharges instead of light. Die sinker EDM is perfect for creating complex cavities and shapes that would be difficult or impossible to machine with traditional methods. We're talking about things like molds for plastic injection molding, dies for stamping metal parts, and even intricate cavities in jewelry. One of the biggest advantages of die sinker EDM is its ability to create deep, narrow cavities with high accuracy. This is because the electrode can be made to very precise tolerances, and the EDM process itself is incredibly controlled. Another advantage is the surface finish that can be achieved with die sinker EDM. Depending on the application and the materials used, it's possible to achieve surface finishes that are so smooth they make a baby's bottom jealous. Now you might be thinking, this die sinker EDM sounds pretty great, but what are its limitations? Well, one limitation is that it can be a relatively slow process, especially when compared to traditional machining methods. This is because the electrode can only erode the workpiece one spark at a time, and the process needs to be carefully controlled to prevent damage. Another limitation is that die sinker EDM is generally limited to conductive materials. So if you're trying to machine something like plastic or ceramic, you'll need to find a different method. But despite these limitations, die sinker EDM remains an incredibly valuable manufacturing process, particularly for industries that require high precision, complex shapes, and intricate details. It's used to create everything from molds for medical devices to dies for aerospace components, and its versatility and accuracy make it an essential tool for modern manufacturing. So the next time you're holding a plastic part, take a closer look. There's a good chance that a die sinker EDM machine played a role in creating the mold that gave that part its shape. And if you're ever lucky enough to see a die sinker EDM machine in action, take a moment to appreciate the magic of sparks shaping metal with incredible precision. Last but not least, we have hole drilling EDM, also known as small hole EDM. Now, as the name suggests, this type of EDM is all about drilling holes, but not just any holes. We're talking about really, really small holes, and we're talking about drilling them with incredible precision. Imagine this. You have a turbine blade for a jet engine. These blades spin at incredibly high speeds and have to withstand extreme temperatures and pressures. To keep them cool and prevent them from melting into a puddle of molten metal, they need tiny cooling holes drilled through them. Now, drilling holes in a turbine blade might not sound that difficult, but remember, these holes are tiny. We're talking fractions of a millimeter in diameter, and they need to be drilled at precise angles and depths to ensure proper cooling. That's where hole drilling EDM comes in. This process uses a rotating electrode, typically made from copper or tungsten, to erode the workpiece and create a hole. The electrode is hollow in the center, and dielectric fluid is pumped through it during the drilling process. As the electrode spins and advances into the workpiece, sparks jump the gap between the electrode and the workpiece, just like in the other EDM processes. These sparks erode the workpiece, creating a tiny, precise hole. One of the biggest advantages of hole drilling EDM is its ability to drill very small holes with high aspect ratios. Aspect ratio refers to the depth of the hole relative to its diameter. So a high aspect ratio hole would be a very deep, narrow hole. Traditional drilling methods struggle to create high aspect ratio holes, especially in hard materials. But hole drilling EDM can handle it with ease. This makes it an essential process for industries like aerospace, where high aspect ratio holes are often required for cooling and fuel injection applications. Another advantage of hole drilling EDM is its ability to drill holes in virtually any conductive material, regardless of its hardness. This is because the EDM process doesn't rely on mechanical force to remove material. Instead, it uses electrical discharges, which means it can cut through even the hardest metals like it's nothing. But hole drilling EDM isn't just about drilling tiny holes in turbine blades. It's also used in a wide range of other applications, like creating microholes for medical devices, drilling holes in hardened steel for tooling applications, and even creating intricate patterns and designs in jewelry. So the next time you see a product that requires tiny, precise holes, there's a good chance that hole drilling EDM played a role in its creation. It's a process that often goes unnoticed, but it plays a vital role in many industries, enabling the creation of products that are smaller, lighter, and more efficient than ever before. So there you have it, the three main types of EDM: wire EDM, die sinker EDM, and hole drilling EDM. Each process has its own unique strengths and capabilities, making EDM an incredibly versatile and valuable manufacturing technology. From creating intricate shapes and cavities to drilling tiny, precise holes, EDM is helping to push the boundaries of what's possible in manufacturing. It's used in a wide range of industries, from aerospace and medical to automotive and electronics, and its impact on our world is only growing. If you're looking for a manufacturing solution that offers unparalleled precision, accuracy, and versatility, EDM is definitely worth considering. And if you're ready to take your manufacturing to the next level, ERODEX is here to help. Thanks for watching. Ready to explore EDM solutions for your business? Contact ERODEX today and discover the power of precision. Don't forget to like, share, and subscribe for more insights into advanced manufacturing technologies.